Hey there, it's Jason from Codemanship with another video diary entry. Before we begin, if you're enjoying these videos, please like and subscribe and ring the bell for notifications. Okay, now in a previous video, I was looking at how we can automate functional tests of our system using something like Selenium WebDriver, so essentially testing a web application through the browser. And I was making the point that those tests, you don't want to end up with a suite entirely made of those tests because they're going to run really slow. And I'm going to use the example, so we'll just recap slightly, use the example of my Guitar Shack Shop Web, say that 5 times quickly, web application. So it's a fictional guitar shop, and we can go shopping and we can add items to our shopping basket like that, and then we can check out and see what's in the basket. And we want to know that all of this logic is working correctly. So we agree a number of tests with our customer, and then we've got choices about where we automate those tests. And the point I was making in the video really was that we would not really want to automate those tests of the logic of the shopping basket at the system level, because those tests are going to run really slow. So you may recall that there were some JUnit tests that were using Selenium WebDriver, the Chrome driver. So this is going to take a while to run. It could take 10 seconds or more. So we've got 6 tests here, and it's going to start a new sort of web session with each test. So it'll open a new browser each test that we do. Off it goes, and it's clicking the buttons and doing all that work for us. And it's much faster than manual testing, but it's way, way slower. It's a very slow way of finding out if the total of items in a basket is calculated correctly. Far better, I think, to test that with unit tests. And then there are other things that we would test at the system level. Okay, so all those tests are passing. It took about 30 seconds. And that's for 6 tests, that's pretty slow. So that was the one point I was making, which is we don't necessarily want to live with these tests on a day-to-day basis because they're really going to slow us down. They're also cumbersome and a bit flaky and so on and so forth. But I also made another point in that video about the test code itself. If you read the test code, there's no hint of a web site. There's no hint of web pages. There's no hint of links or buttons or tables or so on and so forth. It's all written at a high sort of abstract level. There's a basket and we can check out. We can get the total of items in the basket and the number of items in the basket and so on and so forth. We can add items to the basket. So there is a kind of a logical abstraction, a logical representation of the user's experience, the user's interactions with the system, and what actions are they performing and what outputs are they expecting to see. But we've written all of the tests at this level. And this is a good habit to get into, but not just with UI tests, but testing generally. You want your test to know as little as possible about the internal design of the thing they're testing. You want the interactions essentially to be abstracted. And many people have done this. I've done this many times over the years, creating what some people call a sort of a test API for the system. Some people are sort of cotton on to the fact that actually these abstractions could be reused for other purposes. For example, to create a domain-specific language that customers and testers can use to drive the system much more easily. They don't have to go through all the rigmarole of writing tests with Selenium, for example, and we can write a little utility for them that just interprets commands and so on and so forth. So all sorts of good reasons to do this, not least of which is it makes the tests a lot smaller and a lot simpler. And behind the scenes, we've got this thing, the basket driver, that is actually opening web pages and clicking buttons and so on and so forth. So all of the nastiness is hidden beneath this. That also means if the nastiness changes, in other words, if we start changing the UI design, which we tend to do on a regular basis, then we don't have to keep rewriting the test. We just go and look at how the actual mapping works in terms of physical interactions with the system between the logical interactions, add items to basket, checkout, and so on and so forth, and the actual driving of the web pages itself. So we're hiding a lot of that detail, a good idea to do, and decoupling our tests from the implementation details. Now, here's the thing. Once you've gone down this road, and this is something that I've kicked around before but never really done seriously, if you think about it, the logic of the user experience can be reused. In other words, whatever we're building in terms of internal design, the internal model, if you like, of the software that we're creating, it's the same logic, it's identical logic. It's just the mappings are different. This set of tests here are being mapped onto physical web pages, but there's no reason why the basket driver couldn't drive the internal model itself. So that got me to thinking. So I did a little experiment over the last day or so. If we take a look, now obviously there's one implication there, that if we're going to reuse the abstractions we create to drive the internal model as well, we need to be able to do that in the language or on the platform that we've actually implemented the internal model in. It just so happens that it's actually done written in ASP.NET Core. So we've got a .NET Core library with the model in it, and we've got an ASP.NET Core website that drives that powers the Guitar Shack shop. So it would make sense. So I redid this basically, rewrote my tests, my front-end tests in .NET using the .NET version of the Selenium API. And we've got these tests here that, as you can see again, are kind of written at that abstract level. We've got a new basket, we can add items to the basket, we can check to see what the total in the basket is, and so on and so forth. So they're written at that abstract level, the abstract logic of the user experience. But if we take a look at our basket driver, what the test is actually written against, it's this. So there's no implementation, there's nothing that's driving Selenium or anything like that. There's just a pure interface that defines these actions and defines these queries, but doesn't implement them. And that means we can have two different implementations. So one implementation will look familiar, we can find that, our WebDriver. This is actually driving, using Selenium, actually driving the web browser. So this is doing what that Java JUnit version of the tests was doing, implementing the basket driver interface. And we can run these tests. Let's, well, I'm not going to show you the whole thing yet. And we also have a version that drives the internal model itself with a bit of a setup there with data and stuff. So if we agree a bunch of acceptance tests with our customer, for example, we capture a bunch of tests, then we can essentially define tests that are at that abstract level using the data, the examples we've agreed, and then we can repurpose that because we're writing tests at this abstract level. Let's take a look at these basket tests again. There's something you will notice about this test fixture, this NUnit test fixture. It is abstract. We're not going to run these tests, but it's not these tests necessarily that we're interested in. What we can do is we can extend. So for example, for the web version of this, we can, essentially it's the same tests, the same logical tests, the same tests of the logic of the user interactions, but the setup is different. In this one, it's set up with the web basket driver, the one that's actually going to click the buttons. And also there's a teardown there, so there's an extra step after every test is run where it quits the browser so that we don't end up with the same web session between tests. And so our tests are all nice and isolated. Makes them slow though. Let's just run these tests and check they're all passing. So off it goes. So it's going to do exactly what it was doing with the JUnit version. We'll get a new browser session with each test. The identical test cases, basically. Okay. And there we go. So, okay. So it took about 23 seconds or something in total, roughly the same time that you would expect. Okay, so that's still pretty slow. But now, with our model tests, all we're actually doing is setting up with the basket model driver. So that's actually driving the internal model directly. And when we run these model tests, let's run them all. So remember, identical tests, different setups. When we run the model tests, well, let's run it again, actually. 79 milliseconds. I reckon we can do it faster than that. Okay, 56 milliseconds. So it's 90. Okay, it's slowing down a little. So it's orders of magnitude faster than those browser-based tests. And therefore, in terms of getting protection from regressions and stuff, much more useful. We get a nice test pyramid, if you like, where the bulk of our tests run fast. So I'm kind of asking the question in my own mind at this point: why would you do this? Why would you do this? Why would you write the same test that run at both levels? Well, there's a couple of answers to that question. One is you don't end up duplicating the tests. They are the same test. They're just being executed at different levels. And they're describing the exact same logic, the exact same user interactions. So you could have your cake and eat it here, if you wish. You could have your cake and eat it. And then you would retain those front-end tests, the browser-based tests. You would retain those only for when the user interface itself is changed. Only when the layer above has changed, basically. So to test the code in between the internal code that our unit tests are testing and the actual system boundary itself. So only when that code, for example, when the HTML is changed, we better run those tests and make sure we haven't broken the contract that we've defined with the end user. But I'm also harking back to another video I did where I was sort of demonstrating or ruminating on the idea, and I've done this many times, of test driving the user interface, essentially bringing the user experience, the web designer, for example, into the room when we're test driving the system. And at that level, writing, for example, Selenium tests for a user interface, for example, for web pages and elements on web pages that don't exist yet. And so we're capturing the logic of the user interactions first, and then saying, okay, well, in that case, we're going to need a button. In that case, we're going to need a text box. In that case, we'll have to go to this web page or whatever. And we construct a sort of a bare bones, purely functional bare bones user interface that the web designer can then go away. And it doesn't have to be a web designer. You could do this not with Selenium, but you could do this with testing tools for driving iOS apps or Android apps or desktop apps or that kind of thing too. No reason why you can't. But you're defining a contract essentially that says at this level, and whatever UI design you come up with, it has to pass these tests because this is the logic of the user interactions. So it kind of keeps us honest. Now, this is where the idea of having the same abstraction reused and the same tests reused at the internal level and the external level it's becoming clearer in my mind now what these kind of tests could be very useful for. So the idea is that we would go in the same way that we would hopefully normally do, go in and sit down with our customer and agree tests, agree examples for a feature what we're expecting it to do, how will the user interact with the system logically, what outcomes or outputs are they expecting, and so on and so forth. And then we would start to automate those tests. And initially what I'm thinking now is we would automate them at a purely logical level. In other words, we would fake it until we make it. So there would be no user interface and there would be no internal architecture at all. But now we would have a set of tests for that particular feature that we can take away. The web designer can take them away and design a web experience that passes those tests. And we can take the same tests away and come up with an internal model that passes those tests. But it's the same set of tests. It's squaring a circle that I've been trying to square for some time now, which is you don't want to end up with two sets of tests, maybe two different setups, but not two sets of tests, basically. The tests are the same. And if you think about it, the internal logic of our application should be identical to the user experience. It's the same user experience that we're describing. We're just mapping it onto different levels of detail, if you like. Or different levels of abstraction or different levels of layers of architecture. So we are describing the system internally, but we're describing it purely logically, and that same logic applies externally. That's the same thing. But it gives the user experience designer, for example, the web designer, quite a lot of freedom, because we've described the user experience in a very abstract way. So we're just talking at a logical sense of actions and outcomes and so on and so forth. So it's very, very abstract. So how does that actually work? How does adding a product to your shopping basket work? Well, we leave that up to the expert. We leave that up to the user experience designer to say, well, this is This is how we think this should be structured. This is how we think should work. There might even be multiple ways of achieving it, in the same way that in our let's go back to our products page here. There are often multiple ways of doing something. So if I want to look at my basket, I can click on basket, or I can click on checkout, or I can click on continue shopping, or I can click on products and look at more products. So good UI design often will present users with multiple routes to the same goal, essentially, so they're more likely to find a way that works for them. And again, we leave the freedom. They have the freedom to map it however they want. They could have multiple user journeys that have the same outcome, essentially the same test, but we could have different setups to say, well, we're going to do it, we're going to map it onto the UI in different ways. So there's a lot here that this approach might make possible. Now, this is relatively new to me. My understanding is that there are people out there who are certainly advocating and practicing writing abstractions for their tests that hide the detail of how we're interacting with the system. That's pretty common. And there are fewer people, but there are people out there who are creating abstractions in such a way that they can be reused in two sets of tests, external and internal. So my understanding is there are people who are doing that. What I don't yet know, and you can correct me in the comments if you are doing this, or you know people who are doing this, or you've seen it done, is whether people are actually doing this before any UI design or any system design exists at all, to actually fix the contracts between the user and the system, so that we all go away with an executable understanding of the system at both of those levels. Essentially reusing the same abstract tests. So if you've seen this or you've done it, give us a shout in the comments. Otherwise, maybe there's food for thought there. I'm going to carry on experimenting and noodling with this. In the meantime, stay safe. So until the next video diary, that's me out.